One place where we teach that doesn't make a lot of sense because the steps are removed a lot from logic is working with decimals and multiplying. So I would argue that we should estimate and ignore the decimals and use logic to think about what the answer should be at the end. So here's what I mean. 7 8/10 times 1 4/10. I would estimate this to be about 8 times, well, this is tricky. It's closer to 1 than 2. It's about 1.5. So, I would expect kids to understand that the answer is between 8 and 16, so maybe about 12. Kids can perform the basic multi-digit multiplication algorithm, which I've covered in other lessons about ways to make it make sense, but 4 times 8. So at this point, based on the understanding that this answer should be about 12 and using logic, the only reasonable place to put this decimal point is between the 0 and the 9. So the answer is 10 and 92 hundredths. Now, see, the problem with teaching kids the old-fashioned way of saying count the number of decimals and then add those up and then go back, on multiple choice questions, when the answer choices are like this, and so on, kids get confused. They should not get confused by these different powers of 10. Finally, if you have like 2 86 hundredths times 7, that's about 3. 3 times 7 is about 21. The answer should be a little bit less than 21. In here, if we kept the decimal point, then kids would be like, well, do I need to put the 7 under the 2 to line up my place values, which is true in addition and subtraction? Kids get confused at every turn. So by ignoring the decimal point until the end and using logic, it saves them. Basically, greater logic equals more thoughtful responses. This will help kids, I promise.